Hey guys, how's it going? Today I'd like to talk about this latest tweet that Andrej Karpathy made, which goes quite viral. This is almost by the end of year, and he tweeted about new agent and the working dynamic shift. So basically, what he's saying is that traditional programming layers are going to be sort of abstraction layer, and we are going to involve more about agents, sub-agent, prompt context, MCP. Basically, all these, what people call AI, is going to be integrated more closely and will be the essential tools as software engineer, or if you're MLOps or maybe data scientist. It's something that we're going to integrate more and more in future. And eventually, this tweet goes quite viral for several reasons. Obviously, the first reason is that this is sort of like a bug tweet. Everyone reacted their own interpretation. Also, it's the end of the year, so people just have plenty of time to look into the Twitter and just made a comment. But also, yeah, it's good to comment on his um, thought process and just to get aligned with what the sort of the most skilled engineer is talking about. But at the same time, I felt that a lot of people sort of missing and fear or a little anxious about what's going to change or what he's mentioning here and get overwhelmed by what the LLM or agent can do, um, and also feel sort of like urge to learn those skills and some of the missing part. um, that's what I found from this tweet, and it was quite interesting to me. Just to mention that, so I'm a software engineer, but I also have a master degree in data science as well as the 5 years professional engineer, and worked previously in Google Cloud. I also work as MLOps, so platform engineer. Basically, I work and follow this trend from almost beginning when people start talking about AlphaGo. So it's like earlier of the so like AI emergent moment. And if you haven't followed from the beginning, it might be overwhelming or a bit um, difficult to follow what's happening. And of course, there's a lot of tools, a lot of new projects, a lot of new setups going around. So it's quite understandable that people feel overwhelmed and just to uh, try to figure out where to take a next career step. But as an as a person who follow from this the beginning, it is quite expected, and I think that's just how we expect it. And this is sort of the right time, especially at the beginning of the CrowdOps 4.5, which I've been using already quite a lot, and I could say the model performance is very good. So it obviously changed the way we work, and we are no longer ignorant. Um, so yeah, long pretext, but what I'm going to do is I'll introduce how it's been evolving, and so that if you're working on this as a software engineer or the MLOps engineer, AI, whatever, as a software related engineer, it might be helpful just to get sort of like high level overview. And this tweet is not something quite overwhelming or scary, but just what it happens by following what's been evolving since beginning. So it's quite natural and something that you can also get aligned with. And yeah, it just helps you to be relaxed. Um, so let's start. Um, so yeah, he used a lot of jargon here. Let's say the agent, sub-agent, prompt, context. Well, those are all related to what is called LLM. The LLM is the large language models. So this is the what is called advanced AI model. If you're already familiar with the AI model and machine learning model, this is all explained in the diagram. So what people call artificial neural network is here, and deep learning it's more fundamental. So this is what is probably overlapping with the LLM or advanced AI model, and this machine learning model, this is light-weighted, so binary classifiers or maybe regression models, and this is more broad terms encompassing all of them, and a data science just covering with some statistical analysis like Kolmogorov statistic. If you have used oral, and that's previously the statistical tools, those are the data science, so like which encompass all the domains, and basically these are just part of the advanced AI capability, so deep learning or large language model, specifically trained on the massive amount of computation. So NVIDIA is the company making processor, which is called GPU. You also use in the gaming, but this NVIDIA computer system gives you the high computation power because of vector calculation. So the graphic card can operate in the high tensor calculation. So this is also what is called the matrix. So the matrix is the n by n tensor. So you basically calculate if you have learned the linear algebra. It's also a related concept, but this is just a fundamental concept which is applied to all these subdomain artificial intelligence, simply because those models are using mathematical definition of the linear algebra, and this linear algebra works very efficiently on NVIDIA GPU, which is like a graphic card. So yeah, that's LLM that use a lot of training computation, and that's why large, well, quite explicit. And again, these terms are just explaining what this LLM can do, and why it is so significant. It is significant because this capability haven't been discovered before. Traditional coding was some type of completion, which is also very deterministic. So use the term deterministic and stochastic. Deterministic system is predictable, so every variables, well, let's put it this way, the system works as we predict. So if you put x, you probably get, okay, y, and that's all. However, the machine learning or the statistical model, which encompasses all of this artificial neural network, is rather stochastic. So the stochastic model behaves not just 1 + 1 = 2, but it could be more variety of the definition. So you can model weather forecast, stock price. Basically, those are all changing data, and you ingest into the model, and the model has more probabilistic parameters, which uses what I explained, the vector and matrix, and dynamically determines the output value. So in that sense, deterministic model and stochastic model is different. So if we have function, well, probably, yeah, so you are going to have more variety, and this is because the nature of the probabilistic model. And that's exactly what the LLM is about. And yeah, so going back to the context, we used to have type completion, which is deterministic, but this probabilistic model can behave more powerful. Why? Because we have more usage, we have more dynamic usage, in the sense that we can ingest our custom model, custom data, and it can generate the different outcome. So we could, for example, put idea, which what we call now as a prompt, which is basically just English, and that's why this guy also say English will be the next programming language, which is in a sense accurate because we ingest English as an input and use the English language to generate AI code. So in that sense, this model is English and then the code. Previously, it was probably if else or some conditional statement, some logical statement, and then the actual output value. So those are the fundamental shift, and it is more powerful because, of course, this system is a highly complex mathematical algebra. So it has a quite powerful inference capability. And this has been put into real life scenarios, real life use case. I also do as my job that I'm placing, while making the platform, and it is just everywhere. And these tools obviously change the way we work. And then what is agent? So agent is what LLM is about. So LLM is, as I said, large language models. So that's the machine learning model, which just expand out of this data science schema. But then now artificial intelligence, it becomes so powerful that it can generate a lot of different things just from one model. And from that time, along with several framework, now those LLM is called agent. So the agent can not only generate just output, just like the function here, agent can also make a call to the tool, let's say some external API hook, or some tools like terminals, or maybe send a bash script command. Well, those like a basic thing that human do, cd to the folders and then list files. Agent can basically do because of the framework such as LangChain, that is one of the tools that became popular since a couple of years ago. And this is just all the framework that people talk about. Subagent is probably what is along with the agent, and the prompt is, as I say, used in the agent, and agent behave what we guide to. And context and memories are, if you're familiar with the system design, these are not overwhelming at all. These are just to remember what we instruct in the short memory window. So this is also the same context, like a caching in a sense, that we ingest the data and prompt and generate the output out of the context. And permission tools, those are definitely just to make the framework and to make it works. Plugins also, the external providers, and skills and hook, those are just external API router and MCP, model context protocol as well. So yeah, that's just not something very overwhelming per se. IDE is the developer integration, so it's Cursor, if you're already familiar. This is what's been used. So this is a VS Code fork. So it's just a lecture-based terminal that you can learn all those tools. So yeah, again, there's nothing new in terms of the usage. Yes, and so what he said, this is stochastic. Like I explained, this is not a deterministic system, and it's changing entirely. Entities suddenly intermingle with what used to be good old-fashioned engineering. Yeah, so it just used probabilistic models. So like I said, there's not new factors, just all these tools are more stochastic and very powerful probabilistic modeling system. And as long as you understand this foundation, there's not much to uh, to uh, to feel fear, because any new tools are just based on several foundation. And uh, the way you can study is that you hear more and more terms, and you will probably look up those terms eventually. So for example, the retrieval augmented generation, this is um, well, basically the one of the system design that you use two distinctive model, and you first generate, well, you let's say, or let me find a good example. Yeah, so basically this have the retriever and generator, and then the retriever does use the vector what I explained already. It's the um, 2D dimension or multi-dimensional space, just so like direction with the values in it, and it stores in the uh, unstructured database, and it retrieves data with some similarities. So there's cosine similarity, um, probably like L2 distance, but based on those metrics, we can get the closer context. So if you ingest some language token or embedding are what ingested into document stretch, which originally comes from the language, but it's extracted for its semantic in a more arbitrary way, so we can extract and retrieve efficiently for human purpose. So the retrieval augmented generation says when the user add a prompt to this LLM, which is large language model AI, it ingests first the retriever, which is light-weighted. Well, it's also a model, but it's light-weighted. Um, and then it asks question or add the vector of the input prompt into the unstructured database and take the similarity and fetch whatever the document or something preemptively ingested to get or retrieve, pass it to the generator, so the large language model. And the reason we do that is previously machine learning, we every time train a model, we also retrain the model, which is called hyper-parameter tuning. It was quite easy because the model parameter was not as much as a large language model. However, large language model has massive parameters to hypertune. So if you try to retrain the model, it is of course quite expensive, and you end up paying a lot of money. So no one want to do that, obviously. So by this way, people come up with retrieval augmented generation. You can get a picture and then pass it to the generator, the large language model. So the input prompt is passed along with all the values from the retrievers, and then the LLM will returns whatever they found. So it sort of enhanced the capability of what this LLM knows. Um, yeah, so that's just one example. And RLHF, it's sort of similar. technique. It uses the human feedback loop to sort of train the model. There is also depth. This is parameter efficient um, fine tuning, efficient fine tuning. So you use lower dimensional metrics and reduce the training parameters count um, and all the low rank adaptation model. So yeah, those are all the sort of like tools, and you have more chain of thought and stuff like that. But you could definitely check out the archive paper, and they explain what it's all about. The fundamental thing is the same. You just get the basic ideas, and all the new terms or new technique are just to facilitate what's been already in place and make it easy so everyone can use it. And so, sort of like democratizing AI tools instead of just spending a lot of money, because again, LLM is huge and very expensive per se. Um, so yeah, that's just how it goes. And now, since all those tools are in place, that basically LLMs are getting democratized and cheaper to use it. And by this way, people are more exposed to those tools and get first-hand experience. I feel that things are much cheaper and getting better, and it's so like intersection um, of the two line of the things. So you had the price of the, let's say, machine learning, which was constantly getting smaller because we just optimize a lot of price and size compression. And of course, the quality and experience that we have is getting better. And then this is sort of like the moment, if it's, this is a timeline, somewhere the timeline, this is the moment that quality improve and the price goes down, while the perfect moment that these two are intersecting, and it's just going better and better. But this is sort of like a beginning, and that's what he mentioned by this end of December 2025. I hope this explanation clarifies a bit about what's been around, and hopefully this helps some of you to relax and get ready for what's been coming. And that's it, guys, and hope to see you in the next video.